Hello everyone, and welcome back to part 2 of my series here on building a device. In this case, we're building a buck regulator to power a Raspberry Pi from a 12-volt supply, or really we're designing this to be relatively flexible, so a couple of lithium polymer batteries or a lead-acid 12-volt battery or whatever you like. But so we're working on a buck regulator. Last video we worked on selecting some parts, worked on finding, in this case, some more critical components, i.e. the buck converter chip itself, and how we went over that selection process, as well as setting up, kind of what our requirements and goals were for the project. We wanted to be able to supply an amp and a half at 5 volts, something like a 12-volt supply voltage, and we wanted it to be relatively efficient. Since this may be powering devices off batteries, you might as well not waste the battery power unneededly. Some kind of other thoughts we had, major components of the project. You're going to have your switching regulator like we found in our searches last time, the inductors, the output and input capacitors, and then your input and output connectors as well. So this time, we're going to talk about how to make your footprints in your PCB design program. I use Eagle, and so that's what we'll be using today. But really what it comes down to is that when you're selecting parts and when you're going to be building a project, most of your passives, things like resistors, capacitors, are going to be generally pretty standard footprints. And so your design program will most likely have those footprints already there, and so you can just make use of those unless you need to make some specific change. But for specific parts, like in this case, this buck converter, we're probably going to have to make our own footprint, our own schematic symbol, our own device in the program, so that we can make use of this. Because this is specific enough that they're not going to have this in the standard libraries. So, usually, like if we go to Eagle here, I've got my library selected. And, I've got a whole pile of libraries, some from SparkFun, Atmel, Analog Devices, Microchip, etc., the Ava library. So I've got a various selection, but I've also got one that I've created. I've created my own library for any custom parts that I have to make myself. So we'll open this up, and then we kind of get into a couple different aspects here when we're making a device to use. Is that there's two sides to every device. There's the schematic side. When you're looking at a schematic, how does it show up? What's its symbol? How do you connect the wires logically to it? And then there's the board side of the device, where we're laying out the pads, the physical dimensions, any holes, things like that. And so then there's the glue that ties the logical side, how does this fit into the schematic, to the board side of how is this physically constructed. And so Eagle does this in 3 steps. You have your symbol, which will be the schematic side of this. It's basically just a drawing and connection points for the wires in the schematic. Then you'll have your package. This will be the physical layout. You'll define your pads, your holes, your physical dimensions, what layers they go on, silk screens, anything like that. And then you'll have your device. And your device is how Eagle takes the schematic and the package and ties them together. Is you'll select not a schematic, but a symbol. Take a symbol and a package and ties them together. So you'll select a symbol, then you'll select a package, and you will tell Eagle these physical pads on the package are supposed to connect to these logical pads on the symbol. So first off, we will go and create a new symbol. And in this case, we're doing a specific part, and so we're probably going to do a specific symbol new to it. In other cases, like I was talking about with resistors, is like, all resistors are going to have pretty much the same symbol. All photodiodes pretty much have the same symbol. And so you can have different packages that use the same symbol to reference different physical parts, but they all are the same in terms of a schematic. However, this part is unique. It's not really shared with anything, and so we're going to create a new symbol specifically for it. So we'll do AP3503E because that's what our part is. And OK, we'll create the new symbol. And so now we've got an editing window here with a grid, and so we can create that. So I'm going to actually check my grid settings here. Actually, I usually like my grid to be a little bit finer. So we'll do that. And then I'm going to draw a box. So we'll grab our lines tool on the symbols layer, which is just fine. And I'm going to go, and you'll note here that up here in the corner, there's a live kind of gauge on where my pointer is. So I don't know, I'll go by ½ an inch out, start a box, and kind of make a square. So this will be, it goes from minus 0.5 to plus 0.5. Actually, it goes just a little bit extra. I can pull that in a little bit. So we've got a 1-inch square box in theory. On a schematic, the size doesn't matter as much because it's just a schematic. It's just a drawing of the logical circuit. When we get to the board, the package layout, then our sizes will come into play more specifically. And then we start looking at, okay, let's put some pins on it. In this case, we've got 8 pins plus the ground pad on the bottom. They call it the exposed pad, EP, there in the box on the drawing. And so we'll take some pins and let's stick them on here. So we'll do 1, 2, 3, 4, and then I'll put this one a little bit farther off, 5, and then 6, 7, 8, 9. So these will be pins 1 through 8 here, and then we'll leave this as our exposed pad. So I'm done adding pins, so we can stop there. And now we can go and pull in the size of the box a little bit because we don't need it to be quite so big. And now we can start editing the names of these pins, make them a little bit more helpful than P1, P2, P3, etc. So I'm going to name pin 1 based on the drawing up above here. So call it BS. And IN. SW. Ground. Feedback. Compensation. Enable. And soft start. And then last one here will be our exposed pad. Now in the schematic, we'll just connect the exposed pad to ground logically via a wire, and then when we're actually getting to laying out the board, we'll make sure that the ground plane covers both. So that's kind of the general term here. We've got a lot of empty space here in the middle, so I'm actually probably going to bring this in a little bit. I'll grab my move tool, bring each side of the box in by just a tad, and bring the pins over to meet it. I could do a group select here. So if I group select the pins in this side of the box, then I can move them all together. In this case, that's not really what I want. I'd rather just select the pins. Oh, you can also draw random boxes. So I've got those 4 selected. And so now we've got the move tool here. To move a group selection, you actually have to do a kind of a weird key combination. I think on Windows it's Control and right click. On the Mac it's Command and right click. So now I've got the whole group and I can move them together. So got all those, and actually I'll probably come in just a little bit more. So in this case, since they're already attached to the wall, I can grab the wall as well. So, and grab the other side here, and grab the wall. Alright, so that saves us a little bit of room, makes it a little bit cleaner. And then, just as a personal preference sort of thing, I'm probably going to move the whole thing so that this is the center mark here. Center mark is, somewhat more centered. So, something like that. And that's just, because I'm obsessive compulsive or something. So that's that. So we'll do a save here. We're not quite done, but so that's a good first step. Eagle also does special things with text fields. So like text here, we can enter a greater than symbol and name, and place this up there. And so then when we place this part, Eagle will automatically fill in the name. So like resistors, you'll have R1, R2, R3 for the first 3 resistors. We'll define the naming scheme we want to use, but then Eagle will automatically fill in the name for this part. And so that's that. We could add, they also have an option for value, which would be like in the case of a resistor, you'll have a 10K resistor or whatnot. And so then you can set the value of the part, and that will automatically show up. In this case, we don't, it's a chip that, it doesn't have a specific value. So I'll probably leave that off. So in this case, I think that our drawing here is pretty much done. What we could do, to give ourselves a hint, is we can also put AP 3503E on the drawing here. So I'll put that there. So now we know that this is U7, whatever the part number ends up being, and then we also know offhand that it's an AP 3503E. So we have both of those bits of information there, and so that's that. So that's pretty much the symbol aspect of this taken care of. So now let's go and edit our package. So I have a number of packages in my library. I'm not sure I have a PSOP 8 yet. It doesn't look like I do. So let's make a new one. So PSOP 8, and we'll make that. Let's make that new package. And so now you'll see the color changed, and Eagle does this scheme where schematics usually use the white background and boards use the black background, so you know which one offhand you're in without having to take a second glance. So let's go back to the data sheet here and scroll down. Remember, there was a page here on the physical characteristics, the mechanical dimensions. And so an important part to reference here is they put the inch values, which I use because I'm an American, in the parentheses, and millimeter values in plane. So when we're referencing these, we'll always be looking at the second value. So scroll up a little bit here, keep that on the window, and I think that should keep visible everything I need. So the important factors here are, at least, I kind of do through a couple of steps usually, is that, so they're saying here that the spacing between 2 pins is 0.05 inches. So let's check what our grid is. 0.05, okay. So our pads will be on each grid line. And then let's see what they say for the length of the pads. So they're saying they're probably giving the minimum and maximum values they could be for dimensions. The top and bottom of this line is the minimum and the maximum values that they expect these dimensional tolerances to be. So usually I like to go towards the maximum side and a little extra. With pads, and these I don't expect to be terribly much of an issue, but especially leadless sort of devices where you have, um, it may have a pad that comes to the edge of the part, but it doesn't actually have a pin that comes out the side. Making your pads on the board stick out a little bit can help you solder this if you're trying to do it manually. And so I usually like to make them a little bit longer and stick out the side a little bit. So in this case, they also say that the length of the foot, the contact here on the pin, at max would be another at 0.05 inches, and then the width of a pin would be 0.02 inches. So I'm going to draw a surface mount pad, and I'm going to adjust the size. So I'm going to say that this pad is, I'm going to call it, I don't know, 0.75. Make that a little longer than our 0.05 max. And then I'm going to make this 0.025, so that's slightly larger than that. The width doesn't matter as much as the length in terms of making it a little bit bigger, so I think that this is a good value. So put those in, hit enter, and you'll see it updated the size of this. So now I'm going to go and pretty much kind of just randomly place the 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll worry about how they actually get placed relative to each other here in just a moment. Then the other part of this is the exposed pad here on the bottom. They made those numbers really small, so let me see if I can zoom in a little bit. So it looks like they made it 0.099 wide. I'll call that 0.1. And 0.134 tall. So I'm going to probably call that 0.14. So again, we'll do a surface mount pad and adjust our sizes. And so we'll set this to 0.1 and 0.14. Hit enter, and so that's our center pad. So I'm going to place that, centered here on the crosshairs. There is our center mark. I'll stop because I don't need to place any more. And so then now it comes down to placing the external pads, the pins, in reference to this center pad. So we know that usually what they're going to do is they're going to define, so we see that the center pad is here in the middle of the part, and then they set the pins at either side of that. So what we can do is we'll zoom in here, move these a little bit, and actually I'll probably just grab the group of these and move them. So we'll deal with the horizontal adjustment in just a minute, but what I'm going to do is I'm going to grab the group of these and right click the group and where's my properties? Change the I don't know. I'll just do it manually. So I'm going to change these to be offset by another another half step, between these 0.05 increments in the vertical direction, so that when we look at the center of this center pad, instead of going right into a pad, we go right between them. So I'm going to, we got our X and our Y positions, so I'm going to add another 0.5 on there. That's actually not quite what I wanted. I want, there we go, 0.75. Oh, 0.75 I should say. And so that offsets it by a half. So, and then I'll just do that to the rest of these, is add 0.025 to them. So 0.075, 0.025, because it's negative, so less negative is up. And then, so this will be minus 0.075. And so then we'll do the same here. 0.075, 0.025, less, so we'll do 25 and 0.75. Alright, so now we've got them placed vertically and in reference to our center pad. So now the question is where to place them horizontally. And so in this case, they say that the total width between the end of the pads, the end of the pins side to side, is going to be 0.244, i.e. a quarter inch. I'm just going to round up to 0.25. So if we look at our position here, so we go from so negative 0.20 to plus 0.20. So right now we're at 0.4 wide. So we're actually a fair bit wider than we need to be. But that's okay, because we made our pads extra long. And so what we're going to do is we're going to bring in the pads here, these edges of the pad, closer to our center pad. And then we'll still expect that our total width will be wider than what they give on the dimensions here, but that's okay because we're making our pads longer on purpose. We just want to make sure that we get our pads in far enough that we get the pins on there nicely. And so probably what I'll actually do here, make this easy, is I'll do set my grid. I'll set my grid to a bit smaller, specifically half as small. And so now that we've got our vertical positioning on these pads set, and I could have done the grid thing too as well here, I just didn't. We can grab the group and do the whole set like that, and grab the group and do the whole set like that. And let's see here. So if we let's take for example, let's take for example these dimensions. We got our 0.1 and our 0.150, we'll call it, is between this width here and this width here. So that gives, in theory, about 50 thou between these added up. So we've got 25 thou on each side. So we got 0.025 I should say, 25 thou per grid division here. And if we zoom in, we look at our grid, that looks like about what the difference is between our center pad and our external pads. And so when we're looking at this, when we see that that's 25 thou there, 25 thousandths of an inch between these, the exposed pad on the bottom and the edge of the package, and then the pins will come out from the edge of the package. So we've got, it looks like the right separation there. So I'm pretty content with that. So now we've got our pads done. I'll actually just do a quick save, and then I'm going to go and draw some silkscreen here. So we'll go and select a layer here. There's a whole pile of them. I usually use the T-Place, the top placement layer, for my silk screens. And so I'm going to go and just draw a nice little box here to represent the outline of our chip. And then I'm going to say that this top corner here is going to be my pin 1. And so I'm going to make a thicker line right there. And that'll help, I'll probably make this a triangle. And so that'll be my pin 1 reference, is that you'll see a big thick chunk there in the silk screen. And you'll note that, over here, the silk screen gets close to the pad. I don't usually worry about that. The manufacturer of the board itself will pull the silk screen back from the pad. And even if they didn't, it's, the overlap is minimal. I wouldn't expect it to be any sort of issue in terms of soldering this thing. So I'm pretty okay with that. And then again, I'll do a text input with the greater than name entry. And key thing here on making text come out the way it's supposed to look, i.e. the way it looks in Eagle, is instead of font proportional, make sure you choose a vector font. And then, I'll choose a smaller size to make it more reasonable. And so I'm going to call this right there. So that's going to do the same name, U number, when it gets added to the board. Actually, I may make that a little larger. Sometimes the really small stuff is kind of hard to read, and that's a nicer proportion towards the size of the package. So we'll have pin 1 up here, 1, 2, 3, 4, 5, 6, 7, 8, and our exposed pad on the bottom, the name of the device, whatever it ends up being named in our schematic, is going to show up down here. And so that's real nice. So now we're going to name our pins. So that's pin 1, okay. I can leave these be as long as they're named appropriately, because then what we'll do is we'll connect the pin numbers with the device descriptions that we added for the symbol. 5, 6, 7, 8, and I'll probably just name this EP for exposed pad so that we don't confuse it with anything. So we'll save that, and so now we've got this this package done. So now we should be able to create a device. So we're going to create a new device, as we did before. We're going to call it an AP3503E. Yep, use a new device here. And so now we get a device thing where we're going to have our schematic symbol, our symbol that we created. And then we'll choose a package here and then connect them. We don't have a value for it. It's not like a resistor. And so then we'll set a prefix of U. So we'll add that. So we're going to go find our AP3503 and plunk that down right there. And then we will add a new package. And this is a PSOP 8. And so right now it's giving us this exclamation point because uh, the symbol and the package aren't connected yet. And so we can go and click connect. And so now I'll scroll back up here in our datasheet window. There we go. And so then we can connect our pins. So we know that pin 1 up here, is BS, connect. Pin 2 is in, find in there, connect. Pin 3 is SW, connect. Pin 4 is ground, connect. Pin 5 is FB for feedback, connect. Pin 6 is comp. Pin 7 is enable. Pin 8 is SS. And our exposed pad connects to our exposed pad pin here. And so now we got a nice clean check mark, and all the pins are connected in both the package and the symbol into a finished device. We'll do a quick save on that, and that's the most part of it. We can do a nice little thing. We can click here and add a description. We'll call it, the AP 3503E 340 kilohertz 3 amp Cronus DC buck converter. And so this will show up when we're looking for this part in our general library. And so sometimes if I'm feeling extra generous, I will grab the DigiKey link and also throw this in here as well. Okay, so now we've got this data in here. Click save, and so now we've got our package created. We've got the symbol created for it. We've connected them into a device. And so now this device is ready to use in the next segment of our video when we go to create our schematic. And then once that's finished, then we can go and create the board. And then we'll send the board files off to be manufactured and assembled. So we will see you next video for creating our schematic. Thanks for watching.